Hello students, I hope your JEE in January attempt went very well. So now we have in front of us, if you will get, most of you will get, okay, JEE very well. So after that we're gonna start with JEE Advanced. So we're gonna, in this particular video, we're gonna discuss JEE Advanced 2024 paper for physics, okay. First today we're gonna discuss paper 1, then after we will go for the paper 2 also, okay. So now if you see the overall, if you will see the paper 1 was very easy, okay. So what happens in JEE Advanced is basically sometime he gives physics paper easy, sometime chemistry, sometime mathematics, right? So every time when the teacher is teaching, he will always tell the student that take all subjects equally, because you don't know which subject will come easy. If you take preferably more in one subject, maybe that subject will come hard, right? So that happened with in 2024 paper, that physics paper came very easy. We will see here it was almost all the questions are from the notes or somewhat little bit, okay. Somewhere you will be feel little bit difficult, otherwise it was very easy paper. Let's see our first question. So first question is from the unit and dimension, okay. This is also very easy question. What he is saying, a dimensionless quantity is constructed in terms of electric charge E, permittivity of free space epsilon naught, Planck's constant h, and speed of light c, okay. If the dimensionless quantity is written as, this is written e raised to power alpha, epsilon naught raised to power beta, h raised to power gamma, c raised to power delta. This is dimensionless, he is saying, and n is a non-zero integer. Then you have to tell what can be the option possible. So alpha, beta, gamma, delta in terms of n, okay. Very easy question. So he is saying that this quantity is what? Dimensionless. So let's put it as dimensionless. Dimensionless means what? Fundamental quantities. First we will express in fundamental quantities. So I have wrote E as in fundamental quantities. Similarly epsilon naught, h and c, okay. You can use there, but most of the students don't remember this, so use any formula, right? We can use any formula by that and we can write down this thing. Now this, he is saying here that this is dimensionless, right? So what I will do, I will first of all I will segregate everything, like mass one side, length one side, time and current one side, right? So first let's take mass. So what is the power of mass? From here nothing, from here minus beta, if I include this inside. From here what I got? Plus gamma, right? From here nothing. Then comes to the length. Length is from here how much? Minus 3 beta, and from here plus 2 gamma, and from here plus delta. In time, if I check, I'm fundamental quantities. Alpha, only alpha is here plus 4 beta, okay. And from here he is saying minus gamma, okay. And if I go for current, A is here alpha, okay, and we have A here plus 2 beta, okay, is equals to M0, L0, T0, A0, okay. Now this question is notes, very easy. This concept is taught in the notes, okay, very easy concept. What you have to do, compare and put here this also 0, this also 0, this also 0, this also 0, right? Now it will be difficult if I put anything as n and then after I will start solving. Instead of that, put one option by option you check, okay. So I will tell you to, after checking minus beta plus gamma, I will tell you one option, I will tell you minus beta. Let's say I am checking A option, okay. So A option minus of beta. Beta is what? 2n here. So I will put it as 2n plus gamma. Gamma is how much? Minus n, right? So alpha, beta, gamma, minus n. So minus n, okay. Sorry, beta is here, alpha, beta is minus n. That's what I thought. Minus n, right? So how much this came? Minus minus this plus and this is minus. So this came 0. Like that if you check for every option, okay. This is your alpha, this is beta, this is gamma, this is delta, right? So for every option, in this option you will check all, here also, here also, here also, here also. For A option you will get all of them as 0, okay. So my answer will be A option. Like this you have written. Okay. I hope you understood. This is basic concept which is taught you in the notes. Okay. Hello students. Now come to the second question. Now what this question is saying is, an infinite long wire located on the z-axis carries a current I along the plus z direction and produces the magnetic field B vector. The magnitude of the line integration B dot dl along a straight line from the point minus root 3a comma a comma 0 to a comma 0 is given by. Okay, so he's asking this line integral. Okay, before that I know this quantity, closed integral B dot dl. What is this? Mu naught into I in. This I know, right? Mu naught into current passing through this closed integral, right? So before that I will tell you what is the question here. So he is saying this is your, let's say, x-axis, this is your y-axis. Okay, like this. This is your x, this is your y. Okay. Now he is saying that you have current passing through this outside. Okay, I, and you have one line from a straight line from minus root 3 comma a. So means x coordinate minus root 3 and y coordinate a, somewhere here. Okay, so if you check this thing, okay, one point is here and one point is somewhere here, a comma a. Okay, this is a comma a, this is minus root 3 comma a comma a. Okay, this line, in this line he is asking. Okay, now if you calculate here, okay, if you calculate here, this angle will come how much? 60 degree, right? And this angle will come how much? 45 degree, right? Right? Okay, now let's check. So now let's go ahead. I hope that thing is clear. Okay, that much is clear, right? Now if you see here that when current is passing like this, okay, and this is like this, okay, this is a closed loop. Let's say this is A, this is B, this is C. Okay, this closed loop, but he is asking through AB only, right? Not from AC and BC, right? But one thing if you will see is magnetic field will like this only, right? Magnetic field will be like this. Okay, so magnetic field direction, if you check here, magnetic field direction is this side, right? B vector, and your DL vector is this direction, right? Right? Both are perpendicular, so dot product is 0. Dot product is 0. So I can say for this BC and for AC, your B dot DL will be 0, right? So if I calculate for this complete loop or for AB, this is same thing, right? If I calculate integration of in closed loop B dot DL, right? Or I say integration B dot DL for only AB, this is same, right? Because for BC and AC, this is 0, right? So how we write down this quantity, right? How we write down this quantity? Mu naught into I in, that I told you in the starting only, right? This quantity. Mu naught into I in, current inside the. Now how to find out current inside? That you see first. If I see here how I find out the current in, this is like wire, okay? If I zoom in and you have here, this is also actually taught in the, we teach in class, okay? So from the center, this is 45, this is 60, here like this. This is how much? 60, this is 45, I already told here. See, here I told you 60 and 45 because points are given, right? Now 60, 45, so how much is total? How much is total? 360, current I. And this is how much? 105. So how you will write down this quantity? This is your answer, right? How you will write down this? Mu naught into I in. I in will be how much? Total current is I in 360 angle and you have 105, right? This is 60 plus 45. Your I in will be 105 only, right? Here, 105 angle only, right? So this is your current, right? How much this comes? This comes your 7 by 24. Okay, if you cancel out this, this will come 7 by 24 mu naught I. Okay, so your answer will be A option. Understood? Okay, this was closed loop only, but here what we had is, here because it was perpendicular for these two lines, it will be 0 for this two, right? So either I calculate for a closed loop or I calculate for AB, it will be same. That's why he asked only for AB to check your concept, right? But this kind of questions we do in the notes, okay? So this was very easy question. Students, so now comes our third question. So in this what we see is, first read the question. Two beads each with charge Q and mass M, so both have same mass and same charge, are on a horizontal frictionless non-conducting circular hoop of radius R. Horizontal frictionless he said, so horizontal, no mg, nothing we have to worry about, right? One of the beads is glued to the hoop at some point while the other one performs small oscillations about its equilibrium position along the hoop. So along hoop he is performing, is at the center, by taking center as the like main point, right? And it is performing oscillation. So for that oscillation we have to find out square of angular frequency, omega square. Okay, what is the approach? Omega square. So this is a just mix of little bit of statistics, electrostatic and your oscillation. Okay, let's see this question. What he is saying is, basically you have here one charge which is glued, okay, Q charge here fixed, okay, and other charge is here, which is you displace it from mean position and it will oscillate like that he is saying. Okay, how it will happen, let's see. So let's say it displaced, I displaced it theta angle, okay, how much I displaced it? Theta. So here it is the charge particle, okay, let me not mention here. And then after this is the why I am calculating this, because I will have a electrostatics force, right? Kq1 Q2 by R square. So for the distance I am calculating. So this is given radius R. So this is R. So this is theta. So this will be theta by 2, right? This is basic mathematics, right? If this angle is theta by any chord on the center, if it is theta, it will be theta by 2 there, right? So this is R, this is R. So how much is this distance from here to here? Charge to charge distance will be how much? This R, 2R cos theta by 2, right? 2R cos theta by 2, okay? Now come to the main part here. See, this line will go like this, this line will go like this, okay? And you will have a force. So force will be in which direction? Force will be in this direction, right? How much is the force? K Q1. So K, both Q are same, right? I think both Q are same. Charge and mass are same, right? So I can say K Q square by K Q1 Q2 by R square. So R is what? 2R cos theta by 2, right? So this will be how much? 2R cos theta by 2 whole square. This is my force, right? But here one thing we missed. See, this is the tangential, this is the normal direction, right? This is the tangential direction, okay? This is your tangential direction. So if you remember, in oscillation, in angular oscillation, we have studied how we bring the equation, that alpha in terms of theta, how we bring? With the help of torque, right? Right? So there, after you bring alpha in terms of theta, your proportionality will be your omega square, right? That is your answer. So till there, how we go? So you have to remember the derivation, how we did the derivation in the notes, okay? So this is F, and if this is theta by 2. So this will be theta by 2, right? This will be theta by 2. So this is F cos theta, here F sin theta. F sin theta. Understood? Okay? This will be your F sin theta. Now how you will write down torque? How you will write down torque? Torque will be your F sin theta, sin here this will come sine theta by 2, so this will be theta by 2, sorry, okay. So sine theta by 2, okay, into r, about center, right? About center, if I write down the torque, okay, if I write down the torque, this will come the torque, okay. Now torque is equals to f sine theta. So f value, let me put the f value, k q square by, here will come 4 r square cos square theta by 2 into sine theta by 2 into r. Understood? Right? Now what I will do, torque equals to I alpha. Here I can say torque equals to I alpha, because I have to, at the end I have to bring the moment, the alpha in terms of theta, right? So this I can write down I alpha. So I is what? Moment of inertia for this particle. This particle is only performing as the SHM, right? So for this particle, what is moment of inertia? I can say m r square, mass is given m, performing in a radius r, right? This is F force, m r square into I alpha. Understood? Okay. Now see, if angle is very small, I can say here this cos square theta is 1. This is theta by 2 is 1, right? This is already taught to you in the class, okay? And here you will have sine theta by 2 into r, right? So sine theta will be how much? Sine theta will be theta, if theta is very small, right? And 1r got cancelled out. So what you will have, m r square is equals to k q square. Here you will have into r1 got cancelled out, 4 r and 2 will come from here, right? 2r into 2, and if you write down here alpha only, so mr square will also come in denominator, mr square, okay, and here you will have your theta, okay, right? Now that's all, this came your answer, right? But if we go in option, he is writing in epsilon naught terms, right? So there will be one more thing, k, what can I write down? K is what? 1 upon 4 pi epsilon naught, right? K, what can I write? 1 upon 4 pi epsilon naught. So for that, q square will come here, and you have 4 into 2, 8, and 4 will come from 4 pi epsilon naught. So 8 4s are 32. So 32 pi epsilon naught, okay, into here what you will have r cube, m r cube into theta. This term is only your omega square, right? And this is restoring in nature, right? So minus sign I didn't include it, right? So this is only your omega square. Now let's go to the answer here. What you have here? So this will be your answer, 32, okay? Generally what mistake you will make is, if you took here, see here once, one mistake students can make here, and most of them made also while exam. What they did is, if you take here theta, here it will be 2 theta, okay? Here it is theta, so here 2 theta, right? So here it will come 2 theta. So they made one mistake and they take the 16 here, 1 by 16 pi epsilon naught. So that will be not answer, because he is performing oscillation. That's why I read here, I emphasize it. Equilibrium position along the hoop, okay? Hoop center is your main point, right? Okay, not this one. It is about not this one he is oscillating, about this one. You are calculating torque, right? So this angle you have to take, okay? Remember in SHM, right? So if I was performing like this was my R, right? Then it have came there 2 theta. Then you have to take this also, right? But that is not the question. Question is about this, right? So torque I calculated about this, so theta will be also this only, right? Understood? So that's why I took this theta and this as theta by 2, okay? I hope you understood. So here some of the student made mistake and they take this D option. That's why you have to be precautionary. Let's check your answer, give 20 seconds even if you get answer, right? That I told you in previous video for the strategy. So once check your answer again, that anywhere you didn't made the mistake, because this is very important, right? Okay, I hope you understood this thing. Okay, simple easy question. Hello students, so now we go for the fourth question. Okay, so in this question, this is from SHM only. Okay, simple harmonic motion, not that much hard question, easy only. Just we also do one question like that in your notes, because this is basically displacing your mean position, okay, nothing else. Here what he is saying, 5 kg mass block with the influencing the force is equals to minus 20x plus 10, okay. Generally force is proportional to x, here there is a constant also, means mean position is displaced, right, that's all. With the value of x in meter at t equal to 0, it is at rest position at x equal to 1. Rest means what? Extreme position, right? The position and momentum of the block at t equals to pi by 4 seconds. Okay, now see here. What is force given to you? Minus 20x plus 10, right? Now if I take minus 20 common, what I will get? X minus half, right? Okay, so means this is my k, okay? And what is mean position here? 1 by 2, right? Where force is getting 0. At mean position, I know F will get 0, right? Means x equals to half. So I can say that generally your mean position is origin, right? But here he is taking mean position as x equals to half, 1 by 2. Okay, and he is saying it is at rest at position x equal to 1, right? So x equal to 1, he is at rest, right? Means what? X equals to 1 is what? It's extreme position, and x equals to half is what? It's mean position. So this is your amplitude also. Amplitude means amplitude is also half, right? Half meter. The position and momentum of the block at t equals to pi by 4. Now t equals to pi by 4. First of all, calculate the time period of this system. I can say 2 pi under root m by k, m is fast 5 and k is what? 20 here. You can calculate by that. Okay, you get the omega from here and you will get it as. Okay, time period how much came? This is pi seconds. Okay, pi second. T equal to 0, he is at extreme position and he is asking at t equals to pi by 4. Pi by 4 means how much? Pi by 4 means how much? T by 4, right? Fourth part of time period, right? Means where it is, where is the particle came? Starting from here in t by 4. T by 4, where he will come? To the mean position, right? That we know from the SHM, basic SHM this is, right? We will come at the mean position, right? So mean position, what is the velocity? At mean position, what is the velocity? I think velocity is only asking. He is asking the position and momentum, sorry. Position and momentum. So position, how you will answer? Position we know, right? Position, he came to mean position, right? So this what is that? Half meter. X equals to half, right? X equals to half. So x equals to half. How many answers are there? C option and B option, right? Now even you don't have to calculate the momentum, right? Directly you can answer that momentum will not be 0, right? B and C is saying so momentum will not be 0. If he started from here, t by 4 time he will come here and he is going which direction? He is going in this direction, right? So momentum is negative, right? And obviously not 0, at mean position velocity is not 0. So m into v will be not also 0. So this is, I can say directly answer, but still if you want to calculate, you can say directly that m into v, and what is the velocity and mean position? A omega, right? So you can answer by that. Time period you know, so omega you can get. A we already mentioned here, half, right? Directly it will come 5 kg meter per second, and minus is coming because it is going in the negative direction, okay? So that's my answer, C option, okay? I hope this is clear. This is very basic question of SHM, not basic we can say, but this kind of question we do in the notes, that mean position is shifted, okay? And we calculate the position and everything. Momentum is little bit higher order, just multiply with the m with the velocity, right? Momentum everyone knows that, okay? I hope this question is clear. Now comes our next question number 5, okay? So this question what is saying, a particle of mass m is moving in a circular orbit under the influence of a central force F equals to minus kr, okay? That he said F equals to minus kr, and corresponding to that there is a potential energy kr square by 2, okay? Where k is a positive force constant and r is the radial distance from the origin. So r is given as radius of that circular orbit, okay? According to Bohr's quantized rule, the angular momentum is given L equals to n into h bar. H bar is what? H upon 2 pi. H is what? Planck's constant, right? That we know already, right? if V and E, V is the speed and E is the total energy, means potential plus kinetic, the circular orbit, if it is rotating, it has some potential, it have this potential and kinetic energy mv square by mv half mv square. So that sum is known as E. So that we also have to get. So then he is asking which option is correct. Okay. So what he is asking first, see, R square, V square and angular momentum and R relation and total energy expression he is asking. So let's see how to get that answer. Okay. The particle is rotating in a circular orbit. Okay. So I can say the particle is here, let's say. So its force is given how much kr, and that kr will be equals to what? mv square by r. So one expression I have, kr is equals to mv square by r, valid, right? And I also know that L is equals to n into h bar, right? And I also know that L is equals to mvr also, always valid. Angular momentum is what? mvr, right? Now he is asking here, see what? R square, V square and angular momentum. So first R square and V square. So basically I have two equation in R and V, right? Two equation, two variable, I can solve for that. Okay. How we will solve? So first of all, I have this expression. So from here, if I get relation between V and R, so what will I get is V square by R square is equals to V square by R square K by M, right? K by M. Okay. And before going to any other option for calculation of V and R, what I will put is, I will put this V, I know from here. So this I name is as equation number 1. If this I name as equation number 2. Okay. So from 1 and 2 only I will solve all the options. See here how. V square by R square. So V value I can write down from here. This expression, what can I write down? L by MR. L by MR divided by this square divided by R square is equals to K by M, right? Okay. So this answer, how much came? This came M square by R square. So this is R raised to power 4, right? And one M will be remaining. So L square by M R raised to power 4 is equals to K. So Km. So here if you see here, okay, 1 K by M, 1 M he took here, right? So he is not doing that thing. What he is doing is basically R inside and then under root he is taking. Okay. Take the M that side. R square M, M cancel out this side, right? Here how we will do? L M R square inside. So L by M into R square ka whole square is equals to K by M, like that. Okay. So because he is not cancelling out the M. If you see here, I want to create this expression. Here it's also M, here also M. First I cancel out it. So I don't have to cancel out it to make the expression. Okay. So L by, what I got? L by MR square is equals to under root of K by M, right? That I got. Under root by K by M. So my C option I got here. What I got? C option. C is correct. Okay. Now just you have to see this MVR is equals to N upon N into H bar and V square by R square is equals to K by M. By this two equation you will solve for this V square and R square. This V square and R square you can get from that. Okay. How? Just solve it. V square. So we will solve here. V square is equals to K by M into R square from here. So R square value, how much I will write down? N H bar by MV. N H bar by MV ka whole square it will become, right? Okay. From here how much came this? This under root you take both sides, right? So V is equals to K by M. Under root by K by M into N H bar divided by M V will come. So M I will keep here only, V square this time, right? M you take under root, so M cube will become. So V square is equals to N H bar you take in front, under root K by M cube. I think this is only the expression he is asking. See here, so B option is also correct. Okay. I can see B option is also correct. The answer I got here. Now went for the R square. So R square what you will do is, from this two equation only get the R square value. Okay. So how will I get? R square is what? R square is m by k into v square. Okay, v square value I have here, so put that value. From here only you put same thing. So m by k into n h bar under root k by m cube. Okay, so one m got cancelled out under root m and one k root. So this will become n h bar under root m k. Okay, I think this is one option is there. This r square. So this option also I got. Okay, so A is also correct. So this is I got the A. Okay, now he is asking the total energy. One option remaining, total energy expression, right? So total energy, what can I write down? Kinetic energy plus potential energy, right? Potential energy is how much? Kr square by 2. Kr square by 2 plus kinetic will be how much? Half mv square. Half mv square, right? So first of all, I can say half mv square. So v value you put v square. V square I have how much here? V square I have n h bar. Okay, here I can write down or from here. If I see from here, v square is how much? Kr square by m, right? Okay, Kr square by m, right? So half kr square is here. 1 by 2 kr square is here plus half m into v square is how much? V square is from here. V square is k by m into r square. K by m into r square. So this also got half k into r square, right? And this also, so I got k into r square, right? Okay. So k into r square, but here he gave in terms of n h bar and k by m, right? So r square value I can put from here, right? So let's put it k into how much? N h bar into 1 by mk, right? How much is this? I got n into h bar under root k by m, right? I got n into h bar under root k by m, but in expression, in option I have 2 factor here, 1 by 2 factor, right? So this option is not correct. This option is not correct. So okay, total energy how I wrote? Potential plus kinetic. Okay, v square in terms of r I wrote, so I got half kr square, half kr square. So that is kr square. R square value from the option I already verified that this is correct, right? So I got the answer. So I have correct answer A, B and C. Okay. Simple. This kind of questions only comes from this chapter generally. Okay. So this is, he will ask, like most of the time he asks from this chapter. Bohr's model and this, or modern physics question will come for sure in the exam, because this is very topic is very good. Okay. So you can learn it. Okay. And surely you have to do as many questions as possible on this kind of patterns, right? I hope this is clear. Understood? So we have next question or 6th question. 2 uniform strings of mass per unit length mu and 4 mu. So mu and 4 mu are given. Diagram we have L and 2L length respectively are joined to at O point, are tied at 2 fixed ends. So this end and this P and Q are fixed ends, right? The strings are under a uniform tension T. Tension T is in the string. So if we define the frequency, we notice 1 by 2L into under root T by mu, which of the following statement is or are correct. Okay. So here if you see in the options, 2 options are there taking O as node and 2 options are there taking O as antinode, right? So first we will solve for the node part and then we will go for the antinode part. Okay. So taking O as the node. Okay. If you see here, what will the fundamental, he is saying minimum frequency, right? Minimum frequency. So first of all, in the P2O, this is only the answer, right? P2O, this is only the fundamental frequency, right? If you see clearly, right? This is only the formula, right? For L length mu, right? And if I got for OQ part, if I write down, what I will write down? Frequency will be how much? Here it will be 1 by 4L, 1 by 2L. So 1 by 2 times of 2L, that will be 4L under root T by mu. Mu is how much? 4 mu, right? So this 4 to 8. 8, so this became how much? 4. So F is equals to V0 by 4. This will be 1/4 of it, right? So if I consider this as node, then this is the answer, okay? So basically how it will form, let's see. So it will be like this. Taking this as node, this will be your fundamental frequency like this, right? 1, and this is 1/4, right? So this will have 4 times, right? So this will have like this 4, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, like this it will make. Okay, taking this O as a node, right? That's what we got. Now he is saying the minimum frequency of vibration of composite string is V0. Yes, V0. Okay, so this answer is correct. Okay, and antinode thing we will see later on. Okay, antinode we will see later on. First come to C option where he is taking as the node only. It has 6 nodes including the endpoints. Okay, so he is saying it has 6 nodes. So yes, it have 6. Count that. This is 1, this is 2, 3, 4, 5, 6, right? 6 it is coming, right? Including P and Q he said already, including the endpoints, right? And nodes. So is 6 is coming. So this also correct. Now come to the antinode part. Okay, no vibration mode with an antinode O is possible of composite string. We will see that with an antinode O, the minimum frequency of vibration of composite string. So now let's check. Okay, if he said that this is antinode, so how it will express? I'm roughing this thing. How it will express, or let's take to the next page. Okay, what he is saying is basically you will have this point P, this point Q. Okay, fundamental will be how much? How it will look for taking this as antinode? It will be like this, right? Right, and here this is node, this is antinode. So it will be like this, right? Okay, this is in middle. Okay, this is the point O your. Okay, like this it will be. Understood? Okay, now I can say for this fundamental frequency F1, F1 will be how much? I can say this as 2n plus 1 divided by 4l, right? 4l under root of T by mu. Okay, what will I have? 2n plus 1 by 4l into T by mu. This is formula, right? Okay, for same I will write down for this F2. What I will get? 2m plus 1 by, here L is 2l, right? From here to here, 2l length. So 4 into 2l, this will be 8 under root T by 4 mu. This is given 4, right? 4 mu is given here, right? So 4 mu. Okay, so this is, so if he said it is, if this is valid, right? If it vibrates, right? Then no vibration. So if it vibrates, then I can say F1 equals to F2, right? If this is valid, then it will vibrate, right? So F1 equals to F2. Do it. What you will get? 2n plus 1 by 4l into under root T by mu is equals to F2. What you will write down? 2m plus 1 divided by 8, and this will come out of that. So 8 to the 16. 16 L T by mu. Okay. So what you got from here? This is 8, 4 factor. Okay, 4 multiplied this side. So 4 to the 8n plus 4 is equals to 2m plus 1. Right? Right. Okay. So from this expression, if you go ahead, what we can say is 8n plus 3 is equals to 2m. Okay. If you see here, n is an integer, right? N is an integer. So what can I say here is, this integer multiplied by an even number. This is even, right? Even plus odd. What should come? Odd only, right? But here it is even number. Right? Means this will be not valid, right? If these two are integers, positive integers obviously. So even this will become even. Plus odd will be odd, right? So but here we have even number. So this is not valid, right? So I can say, he is saying already here, no vibrational mode with an antinode at O, right? So this is also right. Now he is talking about minimum frequency, that we can't talk because it is no vibrational, right? So this will be wrong. So I got the A, C and D as the answer. Okay. So this is Composite string also we teach in the class, so this is also not that much hard question. Okay, so as I told you already that JEE Advanced paper came very easy. Okay, so you can see by till now it was easy only. Still even the multiple correct also, it is very easy. Okay, I hope this is clear. Hello students. So now in this we have 7th question. We have next question. Okay, a glass beaker has a solid plano convex base of refractive index 1.6. So this have a refractive index 1.6. Okay. As shown in the figure, the radius of curvature of convex surface SPU have 9 cm. So radius of curvature is given as 9 cm. While the planar surface STU is acting as a mirror. Okay. So that downside you have a mirror like that. This beaker is filled with a liquid of refractive index n. So this liquid is refractive index n up to the level QPR. Okay. If the image of a point object at O is at height h, okay, so this is given as height h, OT in the figure, okay, OT. So this is h height, fine, is formed onto itself only. So image formed in this only. Then which of the following options is or are correct? Okay. So which option will be correct? Now how to approach this? Basically this is lens plus mirror combination, right? Okay. So you treat it like this. So you make it bend like this. Okay. So this is like this, vertical if you take. Okay. This is like this. Right? I can draw it like this. So this one is given as refractive index 1.6. Okay. And this refractive index is given as N1, N. Not N1, N only, right? Okay. Let's call this is F1, okay, and this have the F2, focal length, right? F1 and F2 I am calling it. F2, right? Okay, the point is I want to find out the complete focal length for this system, right? For this system, this side you have the, this side you have mirror, okay? So light is coming from this side and going this side like that, okay? Horizontal we are not comfortable, so we will draw vertical, right? Always we draw vertical only, right? That's why. Now let's go ahead, okay? Now what I will do next, I know this formula 1 upon F equivalent is equals to 1 upon F mirror minus 2 upon F of lens. Okay, whatever, how many lenses I put, that focal length I will calculate for composite lenses, right? And I will put it here and I will get the F equivalent. So for this is planar mirror, so focal length is infinite here, right? So what I got, 1 by F equivalent is equals to minus 2 by FL. Okay, now I have to get the FL. So that by that I will get the F equivalent, right? So for that, what I know, what is the formula? 1 upon F equivalent is equals to, sorry, FL. 1 by FL is equals to 1 upon F1 plus 1 upon F2. But I have to calculate F1 and F2 also because I know the radius of curvature and refractive index also, right? So then I will go now for F1 and F2. Then I will put in this formula, I will get the FL. Then I will put that answer in the next expression here also, here, and I will get the F equivalent. Then what to do, that I will tell you. Okay. So let's get 1 by F1, right? So 1 by F1, what can I write down? 1 by F1 I can say n minus 1. So for F1, n minus 1. F1, this n is what? 1.6. So I can say 1.6 minus 1 into 1 by R1 minus 1 by R2, right? Okay. So 1 by R1 will be infinite from that side, it is coming. So minus 1 upon minus 9, right? How to write down this expression, that is already told to you, right? This thing, how to write down, that is in the notes, okay? Obviously, if you are preparing for JEE Advanced, you know the basic things. So this expression, you know already how to calculate. So 1 by F1, I can say this will come 1.6.6 by, this will come plus 9, right? So 9, okay? So from here I got the F1, okay? Now get the F2, 1 by F2 if I write down, this will be n minus 1, n is variable, I don't know n, right? N he said n only, right? And then this will be 1 upon minus 9 minus 1 upon infinity, right? Because one side it have a planar. So 1 by F2 will be how much? n minus 1 divided by, this is minus 9, right? Minus 9. Okay. Now I have to get the 1 upon FL, right? So 1 upon FL will be how much? 1 by F1 plus 1 by F2. So here I already have that 1 by F equivalent equals minus 2 by FL, right? So use that only directly expression. 1 by F equivalent is equals to minus 2 by FL, right? So FL will be sum of these two, right? So sum it. How much you got? 0.6 by 9, and here you have minus n minus 1 by 9. Okay. So if I take this 1 by F equivalent, how much I got? 9 LCM, right? So minus 2 by 9, and this will be minus, this will become plus, right? So 1.6 minus n, this I got. Okay. So now you also know if there are two lenses, one mirror, so system will act as a mirror, right? So this is a mirror first of all, right? This is a mirror. Okay. Which mirror this is? Now if you check the options, from where to where n is ranging, right? N is not going above 1.6. If you see, n is here not going above 1.6, right? Means I can say this quantity is positive, right? But there is coming a negative. So what we call it? This is a concave, right? This is acting as a concave mirror. What happened? This is acting as a concave mirror. That's it, right? Now what can I say is acting like concave mirror. So concave mirror you draw. That's it. Now he said that from h height, the image is making on that only. In concave mirror, when the image makes on the itself only, when it is possible, when it is at the R, right? So h is equals to 2f, right? Okay, when it is at the center. Okay, so h is equals to 2f, that we know. So that's it, answer came. H is equals to 2 times of f. F value you get from here. How much you got? We can say 1 by 2 times of f. So 2 times of f means 2 this side, right? So this will come 2 into f value. Okay, 2f from here. So this side 9 by, so this will cancel out, right? So this will be h2f 9 by 1.6 minus n. Okay, this relation came, right? H is equals to 9 by 1.6. Okay, 1.6 minus n, right? Now this expression you use here in the option. Okay, what you got here expression, let me write down. H equals to 9 by 1.6 minus n. This is the relation between n and h. Now put in the options and get the answers. What you have to do? Put this expression. This is put the value of n, get the h. If it is correct, then tick it. So this and this A and B option you will get if you try to put this answer in this. Okay, check the options. That's it. Okay, I hope this is clear. This question is actually notes based question only. Just he filled it with a beaker, made a language. That's it. Okay. Otherwise, if I tell you directly to do like that two lens are there, then there is a mirror, right? Then you will able to do. But if it gave like that, then you will make confused, right? So that you have to develop. You have to develop your mind should be that much sharp that you can understand what is there. Okay. There is just this liquid is acting as lens. This one lens is given and below surface is acting as a mirror. So this is a combination of lens and mirror. Okay. This is the calculating the focal length. Okay. Why I went for focal length? Because he is saying it is making image on the same point, right? Means it is at the 2f distance, right? Okay. Because at the middle, right? For that I calculated for this composite system f I calculated. Okay. That's why I was going. So this question was also good only, right? Little bit of this. If you made from there to this, then this question is easy. Okay. From this graph, from this diagram, you made this diagram, then this is easy question. Okay. Okay. Next 8th question. Now we have numerical questions. Okay. So that was first single correct, then multiple correct. Now we have a numerical questions. Okay. What is saying? The specific heat capacity of a substance in temperature dependent is given by the formula C equals to KT. Okay, specific heat is dependent. Okay, where K is the constant of suitable dimension in SI units and T is the absolute temperature. If the heat required to raise the temperature of 1 kg, mass is given 1 kg, of a substance from minus 73 degrees centigrade. So minus 73 degree means how much? I can say 200 Kelvin, right? Okay. Till where? 27, right? So 27 means how much? 300 Kelvin. Right? So from 200 Kelvin to 300 Kelvin. Then you have to find out the value of N. Okay. What is N? Here he said, where is N into K? Right? So then value of N. Okay. So heat, this is Q is equals to MS delta T, right? So for the temperature dependent C, we will write down what? MC dt integration, right? This expression is in notes directly. This is the simplest question of this whole paper. Okay. Q equals to MS dt, where temperature is changing from where? From 200 to 300. That's it. Answer given. Okay. Put the value of C here from in KT integration. Okay. If it is not dependent, then we do directly. If it is dependent, then you put the expression of temperature dependent. Okay. So Q is equals to what? M outside 1. It is given directly side, so it became 1. C is how much given? K into T dt integration from 200 to 300. Right. K is a constant out of the expression. T dt integration T square by 2. T square by 2. From where to where? 200 to 300. Right. This is how you write down. Then I think integration you know very well. Okay. K by 2 T square. So 300 square minus 200 square. That's your answer. That's it. So your constant N will be how much? N will be 300 plus 200, 500 into 100 divided by 2. This will be your answer. Okay. So 4, 50, 25, 25,000. This will be your N. Okay. N into K is the answer. So whatever the constant, 300 square minus 200 square by 2. Okay. So that will come 25,000. Okay. So this is your answer. Okay. This is the most easy question in the whole paper. Paper 1. Okay. I hope you understood. Now we have 9th question. A disk of mass m radius r is free to rotate about its vertical axis as shown in the figure. A battery operated motor of negligible mass is fixed to the disk at a point on its circumference. So on the circumference, here you fixed a motor. Okay. On the top of the motor, you fixed a disk of radius r by 2. He is mentioning here. See. Another disk of the same mass, capital M. Mass is same. Okay. Mass is here same of r by 2 and r radius. Okay. But it's fixed to the motor thin shaft. So on the motor, he fixed the radius r by 2 disk. One more disk. Okay. Initially both disks are at rest. So this point you have to remember. You have to pick the information from the question first. Okay. Then only you will be able to solve. So this is the way to read a question, also very important. Okay. The motor is switched on so that the smaller disk rotates at a uniform angular speed omega. Okay. Smaller disk is rotating with angular speed omega. Okay. Okay. If the angular speed at which the larger disk rotates is omega by n, then the value of n is, okay. So let's say this is omega dash, okay, and you have to find out the omega dash in terms of omega. That's it, okay. Now see what the question is saying. Question is saying that there is a disk of radius r, and on the edge you fixed one more disk with the help of a motor. Okay, of radius r by 2. Okay. Now with the help of motor you are rotating this. Okay. With the help of the motor you are rotating this. So let's say this disk is rotating this side with omega. Okay. Now you tell me what will be the sense of rotation of this bigger disk. What will be it? See, because this will rotate, this will create a friction, right? Okay. So on this, the smaller disk, the friction will be in this direction, opposite to its motion, right? And on the bigger disk, it will be upward. So it will be like this. On the smaller disk, it will be opposite this direction. Okay, friction, because its motion is this side. right? So it is both surfaces in contact, so this will slide like this on the upward, right? Above like this. Okay, so friction will be the downward direction. On the bigger disc, the friction direction is upward. Understood? So this friction will create a torque, okay, and this will help him to rotate like this with, let's say, omega dash, okay. But this, if you consider whole as system, this is internal, right? So I can say everything is internal, nothing external acted, right? So I can say angular momentum initial, L initial 0, because everything started from rest, right? So L final should be also 0, right? Let's write down what will be the angular momentum when this is rotating like this and this is rotating omega dash and this is rotating at omega. Okay, now how to write? First of all, for the bigger disc, easier, only rotation motion, right? What you will write down? I omega, right? I, so moment of inertia of the bigger disc will be how much? Is a disc mr square by 2 I into omega dash. That's it, because it is a rotational motion only. Okay. Now plus this disc is doing a CRTM. Okay. Translation and rotational motion both. Translation, it is moving like this, right? With what velocity? With what velocity it is moving? What can I say? What is the velocity of center of mass? Here, VCM for the smaller disc. What is that? Omega dash r, right? What is the velocity of center of mass of the smaller disc? Omega dash r. Okay. So what can I write here? So this is, so MBR. So what can we write? M, that is mass is M only, right? I think M only mass. Yes, M only mass. Okay. So here M, V is what? Omega dash R. And at what distance? It is R, at R distance, okay? And it is always vertical, like perpendicular only, right? So that's not a problem, okay? Both are in same sense, okay? But this one omega of the smaller disc, okay? Rotational motion of the smaller disc is in opposite direction. So that will come in the negative sense, okay? So minus I omega of the smaller disc. What is the moment of inertia of the smaller disc? I mr square by 2. So R is what? R by 2. Mr square by 2 into omega is equals to 0. Final angular momentum is equals to initial angular momentum. I hope you understood this thing. Okay. Now from here, if I solve for omega dash, okay, what I got from here, mr square, here also mr square, here 1 by 4. Okay, this will go that side. This is 1 by 2. This is 3 by 2. Okay, this will come 3, 4, 6, 3. Okay. This will come omega by 12. Okay. So n is equals to 12. Understood? That's your answer. Now we have 10th question. Okay. So he is saying a point source S emits unpolarized light uniformly in all directions. At 2 points A and B, the ratio IA by IB is equals to 2. Okay. This is given information. If a set of two Polaroids have 45-degree angle between their pass axis is placed just before point B, then the new value of R will be. Okay, R means the ratio is asking, new ratio. Okay, let's understand the question. What he is saying, that you have a point source emitting radiation in all direction. Then after some distance, you have A, right? And then after you have B. How I know first A is there? Because IA by IB is 2, means greater than 1, so IA is at more intensity, right? So it is nearby there. Okay. Now related to this, intensity is IA for this point, and for this point it is IB. Okay, that is saying. If a set of two Polaroids having 45-degree angle between their pass axis is placed just before point B. So point A is not affected. First of all, let me write down the information. IA by IB is equals to 2. Okay. Now before point B, he said before point B, you place two Polaroids. So what we know about Polaroids? That let's say this is one Polaroid, okay, and this is another Polaroid, right? And that's all. Now what is happening here? Before whatever IB is coming, intensity, okay, earlier it was coming IB only. Now you place two Polaroids, okay. So IB, when it will pass through one Polaroid, we know it will just get half, right? So it will become IB by 2, right? Then what is the, now this is polarized light, okay. Now it is passing through, how much is the angle between them? 45 degree. So we know when it will pass through this, when it will pass through this, what is the formula of new intensity? IB dash, what it will be? The light which is passing, IB by 2 into cos square theta. What is theta? Angle between them, the polarized angle between them, this 45 degree, okay. So this we have to put the IB dash, the new IB is IB by 2 into cos 45. Cos 45 is 1 by root 2, 1 by root 2 by square. That will be how much? IB by 4, okay. So what he is asking? R is what? Ratio. The new R he is asking. So that is IA upon IB dash. So IA is how much? IA I can write down 2 times of IB. 2 times of IB divided by IB dash is how much? IB by 4. So this came 8. So the new answer is, your answer will be 8. That's it. Very easy question. Okay. This is JEE main level question only. So you have to identify in the paper. Sometime paper comes easy, sometime paper comes hard. Okay. But we have to ready for everything, right? So this paper was easy, scoring, and like as I told earlier also, that sometimes students what they do is they try to skip. Let's say I will skip physics, I will skip chemistry. No. You don't know which chapter will, which subject will come easy, which subject will come hard. Okay, possibly all will come moderate level, possibly one will come hard, one will come easy, but we don't know, right? So we should focus on all the subjects equally, whether it's organic, inorganic, physical, physics, mathematics, everything, okay, with equal time, giving equal amount of time on that, okay, and taking care of all the subjects equally, okay. So now we have next question. A source of sound has frequency 240 Hz and the observer and the source moves towards each other at a speed v with respect to the ground. In case 1, the observer measured the frequency to be 288. So what is measured frequency? 288, okay. So basically Doppler effects question, basic question of the notes only, okay. Nothing extra is there. However, when the observer and the source move away from each other at the same speed v with respect to the ground, in case 2, okay, moving away, the observer measured the frequency of sound to be, new frequency is there, the value of n will be how much? So new frequency is asking when they are moving away from each other, okay. Formula based question, nothing else. F dash is equals to how much given? 288 in first case, okay. 288 is equals to Vs plus V divided by Vs minus V, when they both are coming close to each other, right? This is taught in the class, into 240, 240 only given, okay. From here we will solve relation between Vs and V, okay. So multiply this side, so you will get 288 Vs minus 288 V is equals to 240 Vs plus 240 V, okay. Now if I solve this, take this side, 40 48, right? So 48 Vs, so this we will get 48 Vs is equal to how much this side? 240 plus 288 will go, so this will become 528 I think 528 only, 288 240 528, okay. Now this is the first case. So if you get from here Vs you will get 528 V by 48. So this will cancel out 11 V. Okay, this you will get from the case 1. This you got the equation from case 1. Okay, nothing to name, just one equation only. Okay, now case 2 is saying moving away. So apply that formula. What is the new f dash that you're gonna get? Okay, what you will get in here, Vs minus V divided by Vs plus V, right? Into what is original 240. Okay, 240 is normal. So f dash, how much you got? Vs value you put 11 minus 1, 10V divided by 12V into 240. Okay, so 10 by 12. Okay, 12 to 20, 200 hertz. That's the answer. That's it. Doppler effects, basic question. Okay, just apply the formula 2 times of Doppler effect and the answer came. Okay, in notes we will do many kind of this kind of questions. Okay, this is the basic questions of. Okay, it didn't made you bother too much. Okay, just the basic formula and get the answer. That's it. Okay, so now see the next question. 2 large identical water tanks 1 and 2 kept on the top of a building of height h, okay, are filled with water up to a height small h in each tank. Both the tanks contain an identical hole of small radius r on their sides. Close to their bottom, a pipe of the same internal radius as that of the hole is connected to the tank 2. Okay, tank 2 only there is a pipe connected, and the pipe ends at the ground level. When the water flows from the tanks 1 and 2 through the holes, the time taken to empty the tanks are T1 and T2, and H relation is also given. Okay. Now understand, the tank 1 case is already solved in the notes question. Okay, this is notes question only. Directly integration is done in the notes and you have the answer. But still I will explain here also. See, first of all he is saying in tank 1 is the basic case, where what he is saying is water is filled till small h height and you just have a small hole here. Okay, so let's assume this area, tank cross sectional area is capital A and this area is small a. Okay, so we know at any time t, what is the height? Let's say x. Okay, so what will the velocity of the water coming outside from here? What is that? Under root 2 gx, right? We know already. Now what we will do, just apply conservation of mass, we do and we write down A1 V1 equals to A2 V2, right? With the, if you remember, with the Bernoulli's we write down one more equation to solve, right? A1 V1 equals to A2 V2. How we derive that? Conservation of mass, okay, is flowing. The mass decreasing from here and the mass coming out from here, it is same. Okay, if density is same, then conserve the volume. Okay, so area into velocity. Velocity is what? X is decreasing, right? So minus dx by dt will come. Okay, is equals to small a into velocity is how much? Under root 2 gx. Okay, understood? Now take this root x this side and the dt that side and integrate. Okay, basic integration, 1 by root x integration is what? X to the power n, right? X to the power n integration, I think I don't have to tell you what is that. So you take this root x this side because you know 12th mathematics you have also solved. So this basic. Okay, so from here if you solve for the t1 will come from here. Okay, time will come how much? A by a under root 2h by g. This is not to remember, but when you will solve you will get this. Okay, in the second part I will solve the tank. For tank 2 I will solve the integration also. Hold on. Okay, so t1 will come this value. Okay, now what is happening in the tank 2 that you see? In the tank 2 he said that you have a tank, okay, here like this, and it is on, that was, this tank was also on height h. Okay, the first tank, this tank was also on height h, but hole was here only. But in the tank 2 what is happening? Here you attached a pipe and water is coming here, from here out. Okay, that's what the difference is. Okay, so same thing, integration will be same. Okay, what is here, this is x, okay, and this is capital H, sorry, this is capital H on the tank surface, okay. This is what? This is capital A area of cross section, this is small a area of cross section. Now write down the equation, okay. What it will be? Capital A into minus dx by dt into small a into velocity. Velocity will be how much? Under root 2g x plus h, capital H, x plus capital H, okay. This you can calculate by Bernoulli's, okay. What will the velocity coming? Under root 2g x plus h. You know already approximation is applied that capital A is very big comparison to small a. That is given in the question also. See here, small radius, okay. By this assumption only, obviously you are writing this under root 2gx. Otherwise in denominator there comes a one more factor, right? So that we are ignoring. Small a is how much? Into under root 2g x plus h. Okay, this we know. Understood? Now try to do integration. You know the integration, but still I will explain it. Okay, what we will write down? Capital A by small a is a constant that is outside. Under root 2g is constant outside. Okay, and integration dx upon under root x plus h. Okay, with a negative sign is also there. So negative sign we will take outside. Minus dt let's take. Okay, integration here. X is changing from where to where? You have to remember, x is changing from 0 to h. So initially it is h then 0. So initially h and then 0. Okay. Then there is a negative sign that will adjust, right? So 1 upon root x, same as root x plus a something, right? Some constant, right? So linear, same integration will be there. What is the integration of this? This is at x to the power minus 1 by 2, right? So that will be x to the power plus 1 by 2 by 2, okay? So n plus 1, x root x by 2 will become, it will become root x by 2, okay? That's it, 1 by 2, so 1 by 2 will come now. So 2 root x will become, okay? So if you differentiate this, you are getting this, right? So this is correct. Okay, so if you integrate this thing, what you will get? A upon small a under root 2g, and integrate and put the value. So 2 also came here, multiply by 2, and then root x value, first 0 then h, and there is a negative sign, so adjusted h0. So you will get small h plus capital H minus 0 you put capital H, okay. Negative sign I included, okay. After putting the limit, you include the negative sign, then this will come, okay. Is equals to integration of dt t2. Here time is taking t2 time, okay. Now relation is given between small h and capital H. What is that? Capital H is 16 by 9 of small h, okay. How much is given? Capital H is 16 by 9 of small h, okay. So solve for that, okay. What we will get? Root 2, this will become under root 2. So capital A by small a under root 2 by g, okay. This root 2 get cancel out. Multiply by h, capital H I have to put 16 by 9. So this will become 25 by 9. So this will become 5 by 3, right? 5 by 3 minus 4 by 3. So this will become 1 by 3, right? So this will become 1 by 3 root h times of t2. So t2 came, resolve this. So how much you are getting? A by a. In this kind of terms, if you solve, try to make it. What it will come? Under root 2h by g into 1 by 3. So t2 is 1/3 of t1, right? So now see what he is asking, t1 and t2 ratio, right? So t1 and t2. So t2 is basically, t2 is t1 by 3. So t1 by t2, how much came? t1 by t2 only? 3. That's my answer. Answer is here 3. That's it. This was not solved in the notes. This was in the notes exactly. How to do integration and everything is in the notes. Okay. From many years, not from the last year. Okay. And this is solved. This is little bit of difficult. Not difficult actually. Bernoulli's equation you apply, this you will get. Okay. And then after, just do the same integration, right? Integration is exactly same how we did in there. Okay, so that's how your answer came. So this question also not that much difficult. Fluid mechanics, not basic question, but if you understand the fluid mechanics, you will be able to solve it easily. Okay, now we have our next question. A thin uniform rod of length L at certain mass is kept on a frictionless horizontal table with a massless string of length L fixed to one end. Okay, so this is rod and there is a massless string here. Okay, okay, at point O. So point O, about point O it is pivoting, means rotating. Okay, frictionless horizontal table. Okay, horizontal table means you don't have to bother about the mg and normal. Okay, that is outside and inside the plane, so we don't even bother about it. Frictionless also he said, so no friction. And if the horizontal impulse P is imparted to the rod at a distance x equals to L by N, so at a distance of x from the midpoint of the rod, from the midpoint of the rod at a x distance, you imparted a impulse P. Okay, then the rod and the string revolves together around the point O. So the impulse is imparted in such a way that the rod and the string rotates in a same, like this is not the point, here is no impulse is imparted. Okay, here this point will be no impulsive. Okay, basically what is happening, you imparted the impulse such that this string didn't happen like this. Okay, with the string only it moved like this. Okay, got the point? What can happen whenever, if you think practically, what can happen is, if this is the rod, okay, this is the string here, this is the rod, if you impart an impulse it can move like this, right? But that's what not happening. Okay, this is rotating like this, simple. Okay, so he made the question very simple by saying that the impulse is imparted in such a way that it is rotating with this like that. Okay, nothing is that much changed. Okay, then the rod and the string revolves together around the point O, with the rod remaining aligned with the string. Okay, in such case the value of N is, so basically X value you have to find out in terms of L. Okay, here then you will get the L also, N also. Okay, so now understand. First of all, let's write, let me draw the rod and the string only. This is your point O. About this it will start rotating as you will impart an impulse from the midpoint at a distance x, P. Okay, what will happen? This rod will rotate with omega. Whole system will rotate with omega. Okay. Now two things came by the impulse. What came? One is your omega came to the system. Okay, and your velocity also will come, right? So I can write down here that you will have a VCM also. Okay. So according to simple momentum conservation, we can say that impulse is equal to change in momentum. Initial momentum 0, final is what? M into VCM. That's it. Let's consider it is a mass M. Okay, this is massless, this is mass is here. Okay, M into VCM. Okay, now this is my first equation, I can say. Now second part, what he is saying, that impulse is imparted here, right? So I can write down that first of all VCM, what will be the velocity of center of mass and omega relation. So what can I say, how much is this distance? This is L and this is L by 2. Okay, so VCM is what? Omega into 3L by 2. Okay, this is my VCM relation with omega. Okay, now what is the third equation that you understand? Impulse is imparted on the system here. Okay, so we can write down angular impulse momentum theorem, angular impulse angular momentum theorem, that angular impulse equals to change in angular momentum, right? So here where the impulse is imparted here, right? So it is rotating about this point. So what will be the angular impulse? I can write down P into how much is the distance? L plus L by 2 plus X, right? So L plus L by 2 plus X. This is my angular impulse, right? This is equals to change in angular momentum. So final angular momentum is what? I omega. Only rotation is there, right? I omega, and that's it. So moment of inertia. Now see, for this rod, moment of inertia about this point. Okay. So what will I write down? ICM plus MD square, right? So this is ICM, moment of inertia, about this axis, right? What is that? ml square by 12, okay, and then m d square. So d is how much? L by 2 plus L, okay. So what I will have? ml square by 12 plus m d is how much? 3L by 2 ka whole square, okay, into omega, okay, I omega. Understood? So these are the, so this is second and this is my third equation, okay. Now see, just solve this three equation and you will get the answer, okay. How we will solve? From these two equation I got that P is equals to m into omega into 3L by 2. Now P value if you put here, okay, and omega will get cancelled out, you have the whole equation in what? M will also get cancelled out and your whole equation will come in x only, okay. So I can solve for that, and from here if you solve you will get x is equals to L by 12, sorry, x is equals to L by 18, you will get it, okay. So what is your n? N is this only 18, so your answer is 18 days. Understood? How we will solve? I will tell you again. Here you put the value of this P equals to m into omega into 3L by 2, okay. Then everything will get cancelled out and you will have a linear in x only, okay. So linear you can solve basically. So this question was difficult till the point if you are not able to understand this, what is happening here. Otherwise it was easy question. I will not consider this as easy question because some people will say, sir, you are considering everything as easy. For you it is easy. Not that I am saying. See what is happening again, I will tell you. Basically here, if you think in real life, right, it can possible that it can go like twist like this only, okay, and then it will go somewhat like that, right? But that's not what happening here. He's just rotating in like this, okay, like this it is going, and like this, okay. So complete everything is moving with omega around point O, okay. Understood? Now we have our next question from thermodynamics. So he's saying 1 mole of monoatomic gas. So 1 mole information you have to retain, okay. I will store the information in my mind. Monoatomic means degree of freedom 3, okay. Undergoes a cyclic process. So cyclic process like this. P versus T graph is given in cyclic process, okay. J, K, L, M, J, cyclic, shown in the PT curve. Match the quantity mentioned in the list 1 and list 2, okay. Work done he is asking, complete process, okay. Change in internal energy for 1 J to K only is asking. Heat given in K to L. Change in internal energy of the gas in the process M to J, okay. This is not that much hard question, basic question, okay. Why? Because everything formula and everything is already solved, all the processes, okay. So starting from J to K he is asking, right? So let's solve for the work done. He is asking here total work done, right? Work done in the complete cyclic process. So one by one let's solve for every process work done, right? And then we will add it, that's it. So work done in J to K, right? J to K. So if I see J to K, pressure constant, right? So pressure constant means what is the work done formula? Integration of P dV. So P delta V, or we can say write down NR delta T. P delta V or NR delta T. So what is NR delta T here? N is 1, R into delta T is what? 3 T naught minus T naught. K is end point, right? K is after J only. So according to arrow if we go, right? So this will come how much? Work done J to K is how much? 2 R T naught, okay. Then after work done from K to L, work done in K to L, this is what? Isothermal. Isothermal work done is what? nRT, ln V2 by V1. N is what? 1. RT, T is how much? 3 T naught into ln final volume divided by initial volume, or I can say initial pressure divided by, because pressure and volume are inversely proportional. So I can say initial pressure is how much? P naught, and final is 2 P naught. So P naught by 2 P naught. Okay, generally we write the formula in terms of volume, right? While final volume divided by initial volume. Here in terms of pressure it will become reverse. Why? Because they are inversely proportional at the temperature constant. Okay, that's it. Okay, so how much this came? So this became 1 by 2, so minus 1 by 2. minus will come, okay, outside. So minus 3R T naught ln 2, okay. And then work done in process L2M. L2M. What is that value? L2M is what? Pressure constant again, right? So I can write down R into change in the temperature. So because N is 1, NR T naught, NR delta T. So this will be 3 T naught. Final is T naught. So T naught minus 3 T naught. So this will become work done L2M minus 2R T naught. Okay. Then work done in process M to J. M to J. What is the work done in that process? We can say R nRT ln V2 by V1. So nRT, temperature is T naught only. Okay. ln volume, so pressure, initial pressure divided by final pressure. So 2 P naught by P naught. 2 P naught by P naught. So this will come. Work done in M to J process is RT naught ln 2. Right? That's it. Total work done nikal. Calculate total work done. Total work done is what? Sum of these two. So I can say here 2 RT naught, there minus 2 RT naught, so that will get cancelled out. Okay. And here minus 3 RT naught, and here 1 is there, right? So minus 2 will come. Okay. So I can say minus 2 RT naught ln 2. Okay. Is there any option? Minus 2 RT naught ln 2. So P to 4. P to 4. I can say here we got the P. Okay. So 4 to P. So I can say C option or B option possible, right? So let's solve for now. If I solve for the Q option, here Q part I will solve, then I can get the answer, right? But we can solve for all the parts, not a problem. But in the exam, we have to get the answer as fast as possible, right? So at the Q part only, your answer will end, okay? So let's see what is asking in the Q. Change in the internal energy of the gas in the process J to K, okay? J to K, change in internal energy, okay. Delta U is asking. Delta U in J to K. Okay. What is delta U? So we can say pressure constant. So we can say F by 2 NR delta T. What is the formula? F by 2 NR delta T. Simple. F by 2 what? 3 by 2. Number of moles 1 into R into delta T is what? 2 T naught. How much this came? 3 RT naught. So delta U is came 3 RT naught. So see here 3 RT naught, any option? Third option. So we can say here this came B answer. Move ahead. That's it. Answer came next question. Okay. That's it. So this was your Q. Okay. Now he is saying heat given to the gas in the process K to L. Okay. Heat given K to L. K to L. K to L. This process Q is asking. Okay. So now see what is the Q. Do we have next page? Yes. So K to L. Q in K to L. So Q is what? Delta U plus W. Right? So in this process is what? Isothermal. So delta U is what? 0. Delta U is what? 0. So this will come equal to W only. And W we calculated. W is what in Q2? K to L. K to L here. This one K to L. So this is only the Q. Right? So what is this value? Minus 3 RT T naught ln 2. Minus 3 RT ln 2. This one, obviously, we take the answer right already. So this one is your R. Why? Because delta U is 0. So work done is equals to Q. Right? Now, as option, what he is asking, change in the internal energy of the gas in the process M to J. Okay. M to J, change in internal energy. So delta U. So delta U in M to J process. Okay. Delta U is what? F by 2 NR delta T. So M to J 0. Right? What is answer? 0. So let's check what is 0 is the answer. Yes. S came. That's it. Why? Because temperature is constant. So delta U is 0. Because what is the formula? F by 2 NR delta T. So delta T is 0. Okay. Simple. This question was basic formula based directly. apply the formula, get the answer. Okay, simple basic formulas, just you have to get the answer. Okay, so now we have our next question. 4 identical thin square metal sheets S1, S2, S3, S4, each of side A are kept parallel to each other. This is like this, okay, with each other equal distance D, which is very small to comparison A, between them as shown in the figure. Let C naught is equals to epsilon naught A square by D. Okay, so this is our C naught, where epsilon naught is the permittivity of free space. Okay, now he's asking, he's changing this circuit here. What he is maintaining between 0 and V, 2 surfaces and 2 plates, is something is doing in the options differently. Okay, so you have to find out the equivalent capacitance. Okay, that's your question. Okay, now see here. First he is saying the capacitance between S1 and S4, the initial and final, with S2 and S3 not connected is. Okay, so what he is saying, first P. Okay, so P part, what he is saying, S1, S2, S3, S4 like this. So S1, 1, 2, 3, 4. Okay, so this are about this he is asking, 0 and V, and these are not connected, right? So I can, what can we make the circuit? Here we can say here one capacitor, then this one another. Okay, 3, and that's it, right? 0 to V. This 1, 2, 3. That's it. Between 0 to V. Okay, that's what came. Okay, so how much? This is C naught, right? This is C naught, C naught, C naught. So in P part, what is the C equivalent? I can say 3 capacitors in series connection. So what will be the answer? C naught by 3. Simple directive. Series connection, parallel connection in the capacitor you have already studied, right? So P part, then Q part you come. Okay, this is a question of notes only. Okay, we solve this kind of question, plates connected to each other like that. Okay, now see question. The capacitance between S1 and S4 with S2 and S2 sorted with S3. Okay, S1 and S4. Okay, so he is saying S1, 2, 3, 4 plates, 0 between S1 and S4 he is asking. So S4 at V. Okay, and then he is saying S2 and S3 are sorted. So this you connect. Okay, what you did is you connected this, so they are at the same potential, right? So there is no capacitor here. So I can say what is situation here is you have this one capacitor and then second capacitor. That's it, between 0 to V. Okay, so how much is the C equivalent? C naught by 2. Okay, Q, then after come to R. R is what is saying capacitance between S1 and S3 with S2 sorted with S4. Okay, S1 and S3. So Q, R. Okay. R part, what is saying S1 and between S1 and S3. Between S1, 1, 2, 3, 4. Okay, between S1, 0 and S3, this is maintained at V. Okay, and S2 is sorted with S4. This only is saying, see, S2 is sorted with S4. Okay, so I can say here they are maintained at the same potential but not connected with this one. So I can say here this is, let's say this potential is X. Okay, so what can we say here? 0. So this here, and then after this will be this one, and then after one here. How this came, and try to understand this thing. Let me explain. This is your S1, 0, and this is V. Okay, and this is maintained at the same. So this one is your 1. Okay, and this one is your 2. Okay, and this one is also, you can say this one is also your 2. This is your 4. Okay, and then 4 other surface is connect opposite to the 3, and this is also opposite to the 3, and 3 is maintained at V. Okay, like this you will write down. Okay, one by one you go. Like we can say here 1, then after opposite to 1, what is the surface? 2, right? 2. Then opposite to 2, 2 and 4 are same thing, right? 2 and 4 are same, so they are connected same. Okay, at the same potential. Now 2 is opposite to 3, 2 is opposite to 3, and 4 is also opposite to 3 only. Okay, and 3 is maintained at V. So this is how you will make the circuit. Okay, so this is C naught, this is C naught, this is C naught. So these are in 2, in parallel. So this will become 2 C naught and this is C naught. So how much is the C equivalent will come? This is 2 C naught and C naught. So it will become 2 C naught into C naught divided by 3 C naught. This will be 2 C naught by 3. This is your C equivalent. Okay. Then after next part, C. As the capacitance between S1 and S2 with S3 and S1 sorted. S1 and S2 capacitance. Okay. S1 and S2. See, S part. S1 and S2 and S. What he said? S2 sorted with S3. S3 sorted with. Capacitance between S1 and S2. S3 sorted with S1 and S2 sorted with S4. S3 sorted with S1. S3 with S1 and this one is sorted with this one, like this. Okay. So these are maintained at the same potential, these are maintained at the same potential. So I can say if we call this as 0 V, so this is also V and this is also 0, right? So these all plates are, so let's name the plate 1, 2, 3, 4. Okay. So what can I draw the circuit? I can say here this is S1, right? 1, 2, 3, 4. Okay. This is 1, and then after opposite 2, then 1, opposite 3, other one, and then 3. Okay. This will come like this. Okay. How it came? Opposite to 1, 1 and 3 are maintained, right? So opposite to 1 there is 2. Okay. And opposite to 3. Opposite to 3 there is a 2. And opposite to 3 there is a 4. Opposite to 3 there is a 4. Okay. And 2 and 4 are maintained at the same potential. Okay. So they are connected at the same point. Okay. That's how this came. So these all are in what? Parallel connection. So parallel connection, just add it. Okay. So in S part, let's write down here only. In S part, I have C equivalent is equals to 3 C naught. Which option? Here if you see C naught by 3, first this will come C naught by 3, P, and then after came in Q part, answer came C naught by 2, C naught by 2. So this came Q. Okay. And then after R came 2 C naught by 3. R came 2 C naught by 3. So we can say, okay. And then S part came 3 C naught, right? So this came S part, right? So we can say P to 3, these 3 options are there. Q to 2, Q to 2 also same 3 options. Okay. 3 to, sorry, Q R to 4, this one, R to 4, this 2 only, right? And S to 1, so C option. Okay, what is my answer? C option. So now we have our next question, C, from the ray optics. A light ray is incident on a surface of a sphere of refractive index N. Okay, so a sphere is there. Okay, angle of incidence is theta naught and refraction is phi naught, and then reflects with same angle. We know what is the diagram, right? We'll draw it, don't worry. And then emerges out of the sphere with partial refraction. The total angle of deviation is he mentioned as alpha. Okay. Then measure the quantities. Okay. So first let's understand what is the diagram. Okay. So see here what he is saying. He is saying here this is like this. Okay. First what is happening? This is center. If you take, okay, at an angle of theta naught it is coming. Okay. And then inside with phi naught. Okay. And then again this is, so this will be also phi naught, right? And then again refracts with phi naught, same. Okay. And then this is from the center, this is again phi naught, right? And then again reflects with theta naught. Okay. That's what happening here. Okay. And now he is saying total deviation is alpha. Okay. Total deviation, what he is mentioning is alpha. So first let's calculate the deviation of our every part. First deviation will be how much? We can say theta naught minus phi naught. Okay. And then second deviation That you also have to understand it is clockwise or anti-clockwise, right? Okay. So here second deviation will be 180 minus 2 phi naught. Okay, here 2 phi naught. Refraction you know already. This how to write the deviation. This is notes thing. Okay. Third deviation will be how much? Here again this one is how much? Theta naught minus phi naught. Okay. All are clockwise only. But all are clockwise. Okay. So all will get added only. So del net. What he is saying? What will come? 180 minus 2 theta naught and plus 2 theta naught minus 4 phi naught. 4 phi naught. Okay. Okay. And then we know one more equation we know. What is that? 1 into sine theta naught is equals to n times of sine phi naught. Always valid, right? This is valid. Okay. These are the two equations. Now come to the option. Now see in 3 option P, Q, R, he is taking alpha is 180, right? So if I take alpha 180 and find out the condition, then I will able to solve 3 options, right? So n value I will put later on because alpha I have in 3 options. So I will collectively able to solve 3 options together, right? So let's take alpha 180 and try to find out what is the condition. So this is given alpha, okay? Total deviation is given as alpha. So alpha, if you put alpha 180, okay, what is the condition coming? 2 theta naught is equals to 4 phi naught. So means theta naught is equals to 2 phi naught. Now this you put here, okay? And what we got? Sine of 2 phi naught is equals to n times of sine phi naught. So sine 2a, what is that? 2 sine a cos a, right? So I can write down n is equals to 2 times of cos phi naught. Okay. Now put the value of n according to P, Q, R option and get the value of theta naught and phi naught he is asking. Okay. N is equals to 2. In the P option he is asking, option number P. He is asking n is equals to 2. Okay. So if I put n equals to 2, what I got? Cos phi naught is equals to 1. So phi naught is equals to 0. Phi naught is equals to 0. So phi naught 0. So theta naught also 0. So 0, fifth option. So P. This is P. Okay. So A option or B option. Okay. Because together only you check the A option or B option, because in some part, whenever you will get the answer, you just take and move forward. Okay. We will not bother about too much. Okay. We will not waste the time. That's why continuously you should check the option also. N equals to root 3. Okay. So next option, N equals to root 3. Q part, n equals to root 3 if I put. Okay. In next option also he is putting root 3 only. So both options are Q and R solved together. Okay. Alpha and same he is putting. So root 3. So cos phi naught. Here you put n root 3. So what you got? Cos phi naught is equals to root 3 by 2. So phi naught is how much? 30 degree. And theta naught is how much? 60 degree. Okay. So theta naught 60. Theta naught 60. He is asking in Q option theta naught 60. So this is Q. Okay, this here you can make a little bit silly mistake. This is R. So this is R. Okay. So my answer is 521. 521. 521. 521 is in this. So answer came A option. 521. Okay, but let's answer the S part also. If n equal to root 2 and theta naught is 45. Okay. Alpha I didn't give. Okay. N equal to root 2 and theta naught equals to 45. That's all. So what I have here, come to the basics again. We don't have this condition right now. Okay. S part, n equal to root 2. So let's take n equal to root 2 sine theta naught root 2 times of sine phi naught. Okay. Let's keep the equation like that only. And here he is saying that theta naught is 45. Theta naught is 45. Okay. So then possible values of alpha. Okay. Theta naught is 45. So theta naught 45. Theta naught, put the value of theta naught 45 here. So this will become sine phi naught is how much? Sine phi naught how much? 1 by root 2 by root then root 2 also came, so 1 by 2. So phi naught is how much? This is 1 by 2. So how much is this? 30 degree. How much? 30. So theta naught you know 45, phi naught 30 degree. Put the value here in this equation. Then you will get the value of alpha. So alpha how much coming? 180 plus 2 times of theta naught. Theta naught is 45 minus 4 times of 30 degree. Okay. 4 3 is a 12, 120. So this is minus 120. This is plus 90 minus 30. So alpha came 150. Okay. So alpha 150. Which option? Fourth option. Okay. So this is your S option. So already came, right? So this is your answer. Okay. So this diagram is already in the notes. Okay. Notes are in the module question we will solve. That time we have solved this kind of thing. Okay. So I hope you understood this thing. So to solve first, we saw here. Okay. According to option also you have to click that what should be the condition. Otherwise you will solve 3 times and you will find out you are messing up. Okay. So that's why wherever 2 options are matching with some of the information, then you solve that condition. Okay. Then you will able to do it faster. Okay. That when you practice, that time you have to understand this thing. Okay. So now we have our 17th question and the last question of this paper. Okay. See, the circuit shown in the figure contains the inductor L. Okay. So circuit is this. This one is the circuit. Okay. Okay. This is the circuit and let's read the information first. Okay. Inductor L, capacitor C0 and resistance R0. An ideal battery. The circuit also contains 2 keys K1 and K2. Initially both the keys are open and there is no charge on the capacitor. Okay. At an instant K1 is closed and immediately after this the current in R0 is found to be I1. Okay. After a long time the circuit attains a steady state value I2. Thereafter K2 is closed and simultaneously K1 is opened and the voltage across C0 oscillates with the amplitude V0 and the angular frequency omega naught. Okay. So he's asking some values here. I1, I2, omega naught and V0. Okay. Let's solve for this. See here. First he told K1 is only closed, right? So K2 is open. So the circuit is this only, right? This is only my circuit. Understood? This is only my circuit. So what can I say here? That what is in my circuit? There is a resistance. Okay. And there is an inductor and that's it. I have a battery. Okay, that's it. That's all I have. Okay. Now see, resistance also given. Okay, this inductor is also given. Now initially when you will close this circuit, that time what will happen? This inductor will oppose the flow of the current, right? So at t equal to 0, I can say that the current will flow. That is I1 he mentioned. That will be 0, right? So because inductor will oppose it. Okay. RL circuit. Okay. You know already. Okay. Then at t equals to infinity, means after a very long time he said, right? That time current is I2. And what will be the I2? Voltage of the battery is given, right? 20 volt. Okay. This is given 20 volt. Okay. How the inductor will act? Inductor will act as a plain wire. It will not resist it. Okay. So after infinite time, it will become a plain wire. So there is a resistance and there is a battery only, right? So what will the value? 20 by 5. So I think 5 only. So V by R. This came 4 ampere. That's it. Okay. That's what happening. Now he said suddenly with K2 close and K1 open. Okay. So this circuit got open. So this is not working now. Okay. Here only this is the circuit. Okay. So what is now condition? What I have here is basically, let me put it here or keep it here. It's okay. See, now what is the condition? You have capacitor and you have one inductor. Okay. And you have 4 ampere current. 4 ampere current you have. Okay. So what he is asking now, next thing, omega naught in kiloradians he is asking. Okay. Kiloradians per second, not radian per second. So omega formula, what is the formula of omega? Basic. Omega is what? Under root by L into C. This is already taught in the class last notes formula. Under root L, inductor is given how much? 25. 10 is to power 3 will come here. Multiply by 10 into 10 is to power minus 6 will come. Okay. So this will come minus 9, minus 8, 1 by 25, 5. Okay. So this will come how much? 2000. Okay. How much this is coming? 2000. Okay. So now 2000, this is coming radian per second, but he is asking kilo radian, so that will come how much? 2. Omega is 2 kilo radians. Kilo means what? 10 is to the power 3, right? So omega, so 0, 4. So let me check the option also. What he is saying? The value of I1, so I1 is 0, right? So this is P, and then he's saying the value of I2 in ampere, so I2 we calculated 4, so this is Q. The value of omega naught 2, so this is your R. So answer is P2 1, Q2 3, Q2 3. So these are two options. Then R2 2. Okay, so two options. So we have to check the option number 4. The value of V naught in voltage is, see here. Now basically this is the, okay, now this energy will fluctuate between this and this, right? Energy will continuously fluctuate, right? So just equate it. What I will do, half L I naught square is equals to half C V naught square, right? Energy in capacitor and inductor, right? That's we can write down. Okay. So just equate it. Put the values now. Half got cancelled out. L value is how much? 25 into 10 is to the power minus 3 into I naught is how much? 4. 4 square is equals to here. This is 10 into 10 is to the power minus 6 into V naught square that you have to calculate. Okay, that's it. So from here, if you got the V naught, how much you will get? V naught square, we can say 10 is to the power minus 5. Here 2. You will get 5 from here. This is 4, and this is how much it will come? Minus 2. Here it will come 10. Plus 2, 10. Right? So 5 for the 20, 200. This will become V naught only, not V naught square. Already I am solving the power. Okay, so V naught, this will come 200. Okay, so that's your answer. See, 200, 205th option. Okay, as this option. Okay, you can solve this equation here. So I directly, this is 5, this is 4, right? Already power missed. Okay, minus 3, this is minus 5, right? I think calculations part you can do. Okay. So this was also formula based question. Okay, this is like something notes question only, like we solve this separately and this as separately. This is RL circuit here it became. Okay, then this is energy is oscillating, so equating the energy, that's it. Okay, it didn't went in very much depth in this question. Okay, otherwise he can make it difficult also, asking at a certain period of time. That formula is also in the notes. Okay, so I hope you understood this thing. Okay, so paper was very easy. And paper 2 was little bit of, not we will say difficult, but the way he's writing, we will discuss in the paper 2 only. Okay, I will explain there. So paper 1 was almost all the questions are easy and it was scoring. Okay, so I hope you understood everything. Thank you.